We are discussing laws of motion, Newton's laws. In today's class, I am going to introduce new concept, that is equilibrium concept. This is very important. So frequently we are using this concept. Okay, what is that? Equilibrium concept. This equilibrium, many types. We are studying translational equilibrium. This equilibrium, many types in physics, and here we are concentrated on translatory equilibrium. Translational equilibrium means the resultant force acting on the object should be zero. Okay, even though number of forces acting on the object, the body still will be at rest or moving with uniform velocity. Such a situation we can call it as translational equilibrium. So the number of forces acting on a body whose resultant force should be equal to zero, then we can say that the body is said to be in translational equilibrium. So the resultant force acting on a object is zero. That is, it is null vector. Then we can say that the body is said to be in translational equilibrium. So this translational equilibrium, resultant force is zero. That means let F1, F2, F3 and so on forces acting on a body or object simultaneously. Then what is the resultant force from laws of vector addition? Then resultant force should be equal to F is equal to F1 plus F2 plus F3 and so on. Okay, so this resultant force, this is the summation of all the forces. It should be zero. What is this symbol? Summation, sigma. All the forces should be zero. So it should be resultant force should be zero. That means summation of all x components should be zero. Summation of all y components should be zero. Summation of all z components should be zero. So a vector is zero, then all its components must be zero. Then only there is that vector should have zero resultant. Okay, it should not have any non-zero components. If it has non-zero components, then it is called, we can call it as unbalanced force. So all components should be equal to zero. So this equilibrium, translational equilibrium, then if resultant force is zero, then what is acceleration? So acceleration of the body should be zero. So A is equal to zero. So from Newton's second law, acceleration of the system is zero. This acceleration of the system is zero. We have two possibilities. Okay, the first possibility is body may be at rest. Body may be at rest. Okay, so this acceleration is zero. We have two possibilities. I will write here. Okay, so acceleration is zero. We have two possibilities. What is the possibilities? Body may be at rest. May be at rest. If body is at rest, then its acceleration is 0. Then such a type of acceleration may be, such a type of equilibrium we can call it as static equilibrium. Static equilibrium. Okay. Body may move with a uniform velocity, may have uniform motion, uniform velocity. So if a body has uniform velocity, then what is its acceleration? 0. Then we can call it as, such a type of equilibrium we can call it as dynamic equilibrium. We can call it as dynamic equilibrium. So this translational equilibrium is two types. First one is static equilibrium, the body may be at rest. Second one is dynamic equilibrium, the body may have uniform velocity. In both cases, acceleration of the system is 0. Since if acceleration is 0, the resultant force is 0. Okay? This is the concept of equilibrium. Now, suppose there is a single force acting on the body. I will explain further. Okay? So, suppose there is only one force acting on the body. Single force acting on a body. Cannot be in equilibrium. Cannot be in translational equilibrium. Cannot be in equilibrium. Cannot be. Single force, that is unbalanced force, cannot keep a body in equilibrium. Suppose there are two forces may be in equilibrium, if they are equal and opposite, equal magnitudes and opposite in direction. Okay, then there may be chance of equilibrium. Equal magnitudes, opposite in direction, keep a body under equilibrium. If this condition fails, body cannot be kept in equilibrium. Say for example, there are two forces F1, F2. See how these two forces acts on a point O simultaneously. So these two should be equal and opposite. Then this body is in equilibrium. So minimum number of forces, these should be collinear forces. How it should be? Collinear forces. So what is the minimum number of collinear forces to keep a body in equilibrium? The answer is 2. If there are three forces may be in equilibrium, then those forces must be coplanar. They must be coplanar. That means they should lie in the same plane. So the minimum number of forces to keep a particle in equilibrium which are coplanar will be 3 forces. More than that it is possible. Minimum should be 3 forces necessary. Okay. So if these 3 forces, see, I will explain here. let the three forces PQR O P Q R. I give the name of the forces as PQR. These are the three forces acting at a point O simultaneously. So let three forces, what are the forces? P, Q, R be the forces. Three forces are coplanar, acting simultaneously. Okay, that is the condition. Then there may be chance of equilibrium. See, here if these three from triangle law. So from triangle law, as we studied in vectors, triangle law. If these three vectors are represented by three sides of a triangle taken in order, then the resultant will be 0. See, I am going to construct a triangle based on this. So this is Q, which represents both magnitude and direction. P, see, this will be P. Okay, this is P. P, Q. What I am doing, I will try to construct a triangle with the help of these three forces P, Q, R. I will try to construct a triangle. See, P represents this side, both represents both magnitude and direction. Q represents this force and R represents, see, this is the R. Okay, so R is represented like this. So see how these three are represented. Sides of a triangle. Name of the triangle, let it be ABC. Okay, ABC, name of the triangle. So on this triangle, if these forces we are able to represent as a sides of a triangle, then the resultant will be 0. So what is angle between P and Q? I take it as alpha, P and Q. I will take this angle between Q and R, alpha. This angle between this R and P, I take it as beta. Angle between P and Q, I take it as gamma. Okay, these are the angles I assumed. Angle between P and Q. See, P and Q. So you extend this one. Okay, this will become P. So angle between P and Q is gamma. So this is gamma. Okay, angle between Q and R. Q is here, R is here. Okay, I will extend this one, Q. So this is extend Q. This will become alpha. Okay. Angle between P and R. P and R. So I will extend R. This is R. So this angle be taken. So what I am doing, I am joining tail of the two vectors. So just I am sliding the vector. This is R. Okay. So it will become alpha, this is become beta. Angle between R and P is beta. So this law says that if we, here the triangle law says that P plus Q plus R is, from triangle law we have P plus Q plus R is equal to 0. So what is R? Should be equal to minus of P plus Q. Okay, which is the vectors. So R is the resultant of P plus Q minus. That means whose resultant is 0. That means this particle is under equilibrium. So if three forces are acting on a particle simultaneously, keep a particle in equilibrium, then those three forces should be coplanar, and we are able to represent the sides of a triangle taken in order. Okay, then here this angles, corresponding angles. So from this law we can say that here P by Q, it is from sine law. So we have from sine rule. What we have, this P by this opposite phi. So this P, this is alpha, this angle. So P by sine alpha. I will extend this one is alpha. Okay. This one is alpha. So from sine rule we have opposite sides. So if this is alpha, so P by if this is a straight line, this angle becomes 180 minus alpha. So this angle becomes 180 minus alpha. So P by sine alpha. So from sine rule we have that is P by sine alpha, sine 180 minus alpha. Okay, sine 180 minus alpha. That is, and Q by opposite angle. So this opposite angle is this one. Okay, so this angle is beta. So then this angle becomes 180 minus beta. Okay, so this here it is sine 180 minus beta. That is R by opposite one. So this is R, opposite angle this one. So if this is gamma, this will becomes 180 minus gamma. Okay, this is sine 180 minus gamma. Okay, that is P by sine 180 minus alpha becomes alpha. So sine alpha, P by sine alpha, Q by sine beta plus is equal to R by sine gamma is equal to constant. Okay, so this rule we can call it as, this theorem we can call it as Lamé's theorem. Frequently we can call it as sine rule or Lamé's theorem. That is, if P proportional to sine alpha, what we have? P proportional to sine alpha. That means if magnitude of P will be more, alpha will be more. Magnitude of Q will be more, then beta will be more. Magnitude of R will be more, then gamma will be more. Okay, so if this force will be more, then these two will be divert like this. If this force will be less, then these forces will be like this. Okay, so here the sides of the triangle, this magnitude of the force is represented to its length. So the magnitude of a vector is proportional to length. So we have, since magnitude is proportional to, since magnitude of a force is proportional to length, its length. So we have this side length AB proportional to, this is, I take it as AB, triangle ABC. So what is that? AB proportional to Q. So AB, P proportional to, so P proportional to AC, length AC, and Q proportional to length AB. See the diagram. Length AB, and we have, so what we have, and R proportional to, I will write here only. So R proportional to length BC. So length BC. So this AC, I assumed it as small p, length AB, I assumed it as small q. Length R is proportional to, let it be small r. So we have another expression, that is triangle law. I will write here. Okay. What is that? From this, capital P by small p, capital Q by small q, that is capital R by small r, is equal to constant. So if they are in equilibrium, if three forces, these three forces are represented by the sides of a triangle taken in order, then the resultant is 0. So, and this magnitude of these sides forces is proportional to length of its sides. Okay. And so this we can also call it as triangle law. Okay. Or we can, I used the mathematics sine rule, and this theorem we can call it as Lamy's theorem. Okay. And here, if three forces are represented, three forces are in equilibrium, represent the sides of a triangle, then the sum of two sides, if three forces represents sides of a triangle, then if they are in equilibrium, we can check equilibrium. Sum of any two forces should be greater than or equal to, should be greater than third side. Okay. So sum of any two forces, any two sides, forces are sides, should be greater than third side. So this is the condition for equilibrium. So with the help of this condition, we can check whether the three forces are, that particle, keep it in equilibrium or not. Sum of the two forces should be greater than or equal to third one. Okay. So if this is three forces, so these three forces should be collinear and acting simultaneously. Okay. Suppose there are four forces. Minimum number of forces, non-coplanar forces keep a particle in equilibrium. If this is non-coplanar, I said coplanar, if there are minimum is 3. If they are non-coplanar, the minimum number of forces, non-coplanar forces to keep a particle in equilibrium is, answer, 4. So it requires 4. Okay. Take this one. I will give few examples to understand this. Okay. So take this example. A box of weight 10, a box of weight 10 root 3, a box of weight 10 root 3 newtons is held in equilibrium. Held in equilibrium. With the help of two strings. With the help of two strings. Two strings. Two strings OA and OB. OA and OB as shown in the figure. As shown in the figure. The string OA is horizontal. String OA is horizontal. So I will show in this diagram. Find the tension in both strings. Find tension in both strings. So this is the problem. Okay, I will show the diagram. The string OA is horizontal and this is box suspended, and a string will be like this, which makes an angle 60 degrees. Okay, so this is vertical. Box is suspended. Weight of the box is 10 root 3 newtons. Okay, so this is weight of the box. Now find the tension in the strings. Okay, so let it be a ball. What is this? A wall, fixed roof. This is a side wall. Okay, so with the help of two strings, OA is horizontal and another string OB. Okay, this weight box is suspended with the help of two strings OA and OB. This box is under equilibrium. That means the resultant force will be 0. Okay, so this problem we can solve, okay, by using Lami's theorem. So we don't know the tensions in the strings. Let it be T1 and T2. So what I assumed, let T1 T2 solution, let T1 T2 be the tensions in the string. Tensions in the strings. We want this strings OA, OB respectively. Okay. Now, since this particle is in the equilibrium, so it is acted by three forces, T1, T2, T3. That is W, weight. So, use Lami's theorem. Okay. So we can use Lami's theorem directly. Since these three forces are represented by we can represent Lami's theorem. So I take this one as P, this one I assumed it as Q, this one I assumed it as R. Okay. So apply Lami's theorem. Apply Lami's theorem. Okay. Directly you will get answer. So corresponding angles. In the first step, before going to apply Lami's theorem, you find the angles, corresponding angles. So angle between T1 and W, how much? 90. Okay. So I take this one as the vertical reference. So So I keep with the dots. And this one I assumed it as horizontal. Okay. This is vertical. I assumed. I keep this particle O is at origin. I assumed. So if this angle is 60, then this angle becomes 60. In opposite angles are equal. So if this is 60, this one is 90. So angle between T2 and W is 90 plus 60. Angle between T1 and W is 90. If this is 90, this angle becomes 30. So this angle becomes 90. So angle between T1 and T2 is 90 plus 30. So apply Lame's theorem. What is Lame's theorem? P by sin alpha is equal to Q by sin beta is equal to R by sin gamma. So I am applying this theorem. Just we discuss it. Okay. So P I assumed it as T1. Okay. So what is opposite angle for T1? Angle between T2 and W. 90 plus 60. So that is sin 90 plus 60 is equal to Q. Q I assumed it as T2. So T2 by sin beta, opposite angle. Opposite to T2 is angle between T1 and W. That is 90. So sin 90. Okay. And W by its opposite angle is 90 plus 30. So sin 90 plus 30. Okay. So I want T1. So I am equating these two. Okay. So T1 by sin 90 plus 60. Mathematics. What is sin 90? Second quadrant. 90 plus sin becomes cos 60. In second quadrant, sin positive. That is W. What is W? 10 root 3. It is 10 root 3. 10 root 3 divided by sin 90 plus 30. That is cos 30 positive. Okay. So I want T1. So where I have to write? So I will write here. Okay. So I will write here. So what is T1? 10 root 3 cos 30. Cos 30 is root 3 by 2. I will bring 2 up. Bring this cos 60 this side into cos 60. What is cos 60? What is cos 60? Half. 2 get cancelled. So root 3 get cancelled. So what you will get? T1 is equal to how much you got? 10 newtons. So this is the answer. We want a tension in the strings. So I got a tension in the string OA is 10 newtons. Okay. Then I want T2. So I am equating these two. Okay. So T2 by sin 90 is equal to W by, what is W? W by sin 90 plus 30. That is cos 30. T2 sin 90 1. W 10 root 3. Okay. Wait, cos 30 root 3 by 2. Root 3 get cancelled. So T2 is equal to 10 into 2, 20 newtons. So this is the answer. Okay. So I got the tensions in the strings OA and OB. T1 I got it as 10 newtons. T2 I got it as 20 newtons. Okay. Clear?
the same problem we can solve in another way without by analytical method. Okay, so I will give that one also without using this Lamis theorem. So without using this Lamis theorem, I want to solve this problem. Okay, second method, we can solve this same problem in different way. Let us see how I am solving. Okay, so this O is the particle. How many forces are acting on it? T1 represents the forces, T2 and W. Okay, so you assume a coordinate system, x-axis and y-axis. So I assumed this one as y-axis, this is negative y-axis, this is negative x-axis, this one is positive x-axis. Okay, so this angle is 30. Okay, and this is 30. So now I am equating, I resolve this force T2 into components. So it will becomes, this components becomes T2 sin cos 30. So since this is theta 30, so its component in this direction is T2 cos 30. Its component in this direction is T2 sin 30 or T2 cos 60. So this one is T2, I will write sin 30. Okay, this one I resolved. Since it is horizontal, its vertical component is 0. Since it is vertical, its horizontal component is 0. Okay, so in this method, just you resolve the forces into its components in a plane. Okay, now equated these two. So from equilibrium concept, so concept of equilibrium, what is concept of equilibrium? Resultant force is 0. What is resultant force is 0 means summation of all x components should be 0, isn't it? So what is x component here? T2 sin 30, T2 sin 30 x component. This is minus x component, that is minus T1 is equal to 0. You call it as equation 1. From this equation we have what we have, T1 is equal to T2 sin 30, or we can say that T1 by T2 ratio of tensions. Suppose you want ratio of tensions in the problem. So what you will get, T1 by T2 is sin 30. Sin 30 is half, 1 by 2. Whether check you got ratio of tensions 1:1:2. T1 I got is 10 newtons, T2 I got it as 20 newtons. T1 by T2, 10 by 20, 1/2. So it agrees with this. But we want absolute values of T1 and T2. So I got another equation. So this is the first one. Second one is I am equating y components. All y components should be 0. Okay? Summation of y components should be 0. So what is y component? T2 cos 30 is positive y component. Negative y component is W. So minus W is equal to 0. So T2 cos 30 is equal to W. What is W? T2 cos 30 root 3 by 2. What is W? W is we got 10 root 3. 10 root 3. So root 3 get cancelled. So T2 is 10 into 2, 20 newtons. So I got T2 as 20 newtons. See, I got T2 20 newtons. If T2 20 newtons, T2 20 newtons, what is T1? T1 is T2 by 2, 20 by 2. So I got T1 is, from equation 1, T2 by 2. That is 20 by 2. I got it as 10 newtons. So I got absolute values of T1 and T2. Okay. So this problem I solved in two different ways. First one is by using Lame's theorem. Second one is by using the concept of equilibrium. Okay. Sigma, just I equated sigma fx is equal to 0. Sigma fy is equal to 0. This is the concept of equilibrium. That is, left side forces balances with the right side forces and the top forces balances with the downward forces. If all forces are balanced, then the resultant force is 0. Clear? Take next one. Okay, you take next problem. Find normal reactions Na and Nb as shown in the figure. If M is mass of the sphere, M is mass of the sphere. Okay. So there is a sphere. Let it be a roller. Okay. Let it be a big roller. So this roller, it is balanced between two cliffs. This is one cliff and this is another one, like this. Okay. So these are the two supporters, fixed supports. What are these two? Fixed supports. Two supports for this sphere. So if O is the center of the sphere, this angle it is given, this angle it is given. Okay. This angle is given as 30. This angle is given as 60. Okay. This point A, this point is B. Okay. So this is the given problem. What we want? Normal reactions at A and B. So this sphere is under equilibrium. So find the normal reactions Na and B as shown in the figure. So from the figure we can understand that this sphere is under equilibrium. So it is in a balanced state. Balanced state. That means it is under equilibrium. So we want normal reactions at A and B. Okay. So it is under equilibrium. So this is a problem is also under the concept of equilibrium. Okay. So you assume M is mass of the sphere. Let O be the center of the sphere. So by taking this center of the sphere as center of the sphere, you can assume as a point mass and you try to draw FBD of this sphere, free body diagram of this sphere. Okay. Let us see. This is the O is the origin. So this force is acting on it, which is at an angle like this. Like this. I extend this one. So this is the normal reaction Na. Okay. Since this is the point where this weight of this, a part of the weight is incident touches this A and a part of the weight is at B. So the entire weight of the sphere is supported by these 2 points. Okay? So this sphere weight exert at B and A. So the sphere, according to Newton's third law, it exerts force on these 2 supports A and B. In turn, this supports exerts force on the sphere in upward direction. Resultant force acting on this sphere should be 0. That is the concept of equilibrium. So now I will try to explain what are the forces acting on the object. First you trace what are the forces acting on the object. Okay? So I take this O is the object. What is the forces acting on this? Normal reaction at A. So I assumed it as NA. And here it is contact. So this is a contact force. Normal reaction will be here. So how it will act? Normal to the surface. So this is NB. We want NA and NB. You extend this. One more force is there. Can you say? This weight of the sphere. What is weight of the sphere? If M is mass of the sphere, then its weight is mg. From where it will act? We are assumed that for symmetrical bodies, small and regular shaped bodies, the center of gravity, the entire weight of the sphere acts from its center of gravity. Okay? Now these are the 3 forces acting on the sphere. What are the 3 forces? Na, Nb and mg. Okay? So I will use this one. Na, see, Na, and Nb in this direction, Nb, and weight of the sphere mg. Okay? These are the forces acting on this sphere O. So if you extend this one, okay, if you extend this one, if this angle is 60, this angle is also 60. If this angle is 30, you extend this one is 30. So this angle is 60 and this angle becomes 30. Okay. So you apply Lami's theorem. So to get Na and Nb. So apply Lami's theorem. You will get answer. So what is Lami's theorem? Na by opposite angles. So what is opposite angle? This is 30. This angle is 180 minus 30. So sine 180 minus 30. Okay? That is P by Q. What is Lami's theorem? As I explained, P by sine alpha, Q by sine beta, R by sine gamma. This is the statement of Lami's theorem. Okay? So P I assumed it as Na by opposite angles. Sine 180 minus 30 is equal to Q, Nb, opposite angles. Nb opposite is Na and Mg. This angle is 180 minus 60. So sine 180 minus 60, Mg, weight of the sphere, by opposite angle is angle between Na and Nb, 30 plus 60. So answer 90. So I want Na. So I am equating these two. So what I get? Na by sine 180 minus 30. What is 180 minus 30? You will get sine 150. Sine 150 can be written as sine 150. Okay, is equal to mg by sine 90. Okay, sine 90 becomes 1. So I want Na. So I am writing here. Na is equal to mg by sin 90 1 sin 150. What is sin 150? Can you say? Sin 150 90, it is 60, 90 plus 60 150. Sin 90 plus 60, 90 plus 60 means second quadrant pass to, you will get cos 60. So what is cos 60? So cos 60 becomes half. So it is, you will get Na is equal to mg by 2. Okay, so this is the answer. So I got normal reaction at A is mg by 2. Clear? Next, the next one is, I want NB. So equated these two. So what is that? Equated these two. Okay, I will write here. NB, okay, sin 180 minus 60. How much? Sin 120. mg sin 90 1. Okay, NB is equal to mg into sin 120. Sin 120 can be written as 90 plus 30. You will get cos 30. What is cos 30? Cos 30 root 3 by 2 mg. So normal reaction at B is NB is equal to root 3 by 2 mg. Okay, the same problem you can solve by analytical method also, as I said earlier. Okay, second method, you try to solve. Okay, that is left to you. Take this.